Okay, we got to constructors. What is a constructor? A constructor is a method that is called when an instance of a class is created. Why do we need a constructor? The intention is to put an object in an earlier state. That is, to initialize some of the fields in the class. Here is how we declare a constructor. So as you see, we have a class called customer, and this class has a constructor as you see here. A constructor has the exact same name as the class, and that's a requirement. If you change this name, the compiler or the runtime will not treat this as a constructor. Also note that constructors, unlike other methods, do not have a return type, not even void. Here in this method, we can do any kind of initialization that is required. Note that we don't always have to use a constructor, but if we need to initialize an object upon creation, that's where we put our code. In this example, we have what we call a parameterless or a default constructor. So this constructor has no parameters. If you don't define a default or parameterless constructor for your class, the C# compiler creates one for it. You're not going to see it, but it will be in the IL or intermediate language code that will be the result of the compilation. That constructor doesn't do anything. It just initializes the fields of the class to their default values. What are those default values? For any kind of numbers, it sets them to 0. For Boolean types, sets them to false. For any other kind of reference types like strings or any other objects, sets them to null. And for characters, sets them to an empty character. Here is another example of a constructor. In this example, we have a parameter here. So we get the name of the customer and we set the name field as you see here. Note the use of the this keyword. This is a keyword that references the current object. Why do we need that here? Look, here we have two identifiers that look very similar. We have this name field in the class and this name parameter in the constructor of this class. They both have the same spell, but are using different naming conventions. This parameter here is using camel case, so the first letter of the first word is lowercase. The name field here is using Pascal case, so the first letter of the first word is uppercase. It is possible that sometimes we make a mistake, and in the assignment operator here, we put the wrong variable on the wrong side of the equation. In this example, we are passing this name here, and we simply copy that to this name field here. And that's the right way to do it. But imagine what it would look like if it was the other way around. It wouldn't make sense. That's why we use the this keyword here to make sure what we have on the left side of the assignment operator is a member of the class, in this case, the name field here. So what we get from the outside, which is in this case the constructor parameter, will be copied to the name field. Okay, with that constructor, when we create a new instance of customer, we can supply a name here. At this point, the constructor will be called, and the string that is passed here will be copied to the name field. We have a concept called constructor overloading. Overloading means having a method by the same name but different signatures. What do I mean by a method signature? A signature is what uniquely identifies a method. That is its return type, its name, and the types and numbers of its parameters. In this example here, we have 3 constructors, so we have overloaded the constructor for this class. Each constructor, as you see, has a different signature. So the first one takes no parameters. The second one takes one parameter of type string. The third one takes one integer and one string as parameter. Note that the names here do not matter, but the data types for the parameters and the order of them is important. So we cannot have 2 constructors with the exact same signature. Now you might wonder, why do we need to overload constructors? The reason for that is to make initialization of this class easier. Sometimes we may know only the name, so we may use this constructor when creating an instance of this class. Sometimes we may know both the ID and the name, so we use this one. Or sometimes we may know neither of these parameters, so we may use this constructor here. Okay, let's start coding and see constructors in action. Okay, let's start by creating a customer class. So, public class customer. Now we declare a field. public integer ID, and another one, public string name. Before I move on, I need to clarify something here. In the real-world applications, we do not declare fields with the public access modifier as you see here. This is just because I want to take things in a step-by-step fashion. When we get to the lecture about properties, you will see a better way to declare fields. For now, let's just keep things simple and learn everything in a step-by-step fashion. Okay, now let's put this customer class in a separate file. Here I'm using ReSharper. If you don't have ReSharper, I highly recommend you to purchase a license for it because it really helps you with your coding. Note that I'm not a ReSharper affiliate and I don't get a penny from promoting their product. I just believe ReSharper takes coding to the next level. It makes it much easier and much faster. Alright, let's put this class in a separate file. So I put the cursor here and note this little icon here. That is used for refactoring. That means changing the structure of the code without changing its functionality. So here I press Alt and Enter, and it pops up this context menu here. The first item says move to another file to match type name. So I just press Enter, and note that now we have a separate file called customer.cs, and this file is added to Solution Explorer. So if I didn't have ReSharper, I had to go here, right click, and then go to Add, and hang on, you don't see that here in the screen. So I put the Solution Explorer to the left side. Okay, so right click, Add, New Item or Class, which would open up this dialog box here, and then here we had to type customer.cs. It's really not a good and fast way, because as a professional programmer, you don't want to switch to mouse while you're coding. You should learn to do everything with keyboard. That's much easier and faster. So let's not worry about creating a new file and use ReSharper from now on. I put this Solution Explorer back to where it was. There you go. All right, now let's go to the program.cs here in the console application and create a new instance of this customer. So customer equals new customer. Or a better way is to use var instead of customer, because note that here we are repeating this customer word twice, and that makes the code slightly cluttered. So we can just use var here and let the compiler figure out that customer is of type customer. So the code looks a little bit cleaner now. All right, now I want to show you the effect of the default constructor that the C# compiler creates for us. Note that here in the customer class, I did not create a constructor. But I told you earlier in the slides that the C# compiler creates one for us. So let's see what happens. Let's display the fields of this customer class on the console. So console.writeLine, customer.id, and console.writeLine, customer.name. Note that the way I typed console.writeLine was via what we call a code snippet, which is much faster. So I didn't type console.writeLine. I just typed CW and pressed tab. This is what we call a code snippet. It's a quick way to write code. There are many code snippets in C# and I have explored many of them in my course Double Your Coding Speed that you can find on Udemy. So let's move on for now. Okay, now let's put a breakpoint here. We can put a breakpoint using F9. And we run the application in the debug mode using F5. Okay, I'm going to put a watch on the customer object here. So customer, let's expand this. Note the default values assigned to these fields here. So ID is an integer and the default value for the integers or any other kind of numbers is 0. Name is a string and the default value for strings or any other kind of reference types is null. So this happened by the default constructor that the C# compiler created for this class. Okay, now let's declare a constructor and see how we can initialize this field upon instantiation of a customer. So I stopped the debugger using Shift and F5. We go to the customer class. To do that, I simply press Ctrl and Tab. Look, we got the open windows here in Visual Studio. I didn't have to go and grab my mouse, go to Solution Explorer and double click customer. All right, now here, let's declare a constructor. To declare a constructor, there are two ways. The slow way is to type public and the name of the class and the curly braces. What is the fast way? You type ctor, as in short for constructor, and note the icon for the code snippet here. So that's a code snippet. Here we can press the tab. There you go. We got the constructor. So this is how I want you to code. I don't want you to type every letter. As a fast coder, you should know all your shortcuts. You should code like a ninja. Okay, now let's give a parameter to this constructor. So I go here and let's say integer ID. And here we need to copy that to our ID field. So I type in this dot. Note here are the members of this class. So here's our ID field equals ID. Now let's overload this constructor. So I'm going to create another one with a different signature. Again, ctor, we got here. Now this time I want to add two parameters, int ID and string name. Okay, now let's initialize them. This.id equals ID, this.name equals name. Now if we go back to our program class, again using Control and Tab, here note that we got a red underline. And that's because the compiler cannot find a default constructor that is parameterless. So we can no longer create a customer object using this constructor because it doesn't exist. So what does this mean? That means because we created two custom constructors, the compiler will no longer create that default or parameterless constructor. So if we still want to have this freedom to create a customer object without supplying any parameters upon instantiation, we need to go back here and create a default or parameterless constructor. So ctor, that's it. In this case, I'm not doing anything here. Back to program. Note that the red underline is gone. But also, when we open the bracket here, note that here we have three overloads for the constructor. One is without any parameters, one takes an integer, and one takes an integer and a string. Let's use the third one. So I set the ID to 1 and the name to John. Now we run the application. Note that ID is initialized to 1 and name is initialized to John. And that's the intention of using constructors. Okay, now let me tell you a best practice. Let's get back to our customer class. See, in this case, our customer class has only two fields. And we have created different variations of these constructors here for initializing these fields. What if we had 5 other fields here? Would you go and create 7 other kinds of constructors for initializing each of these fields? No, definitely not, because that would create a lot of clutter in the class. We only use constructors in classes in situations where we really want to initialize that object to an early state that is really important for that object to perform. In this simple example we have here, it doesn't really matter whether the customer object has an ID or not. Same goes for name. We can always create a customer back here. Let me remove these two parameters. We can always create a customer object and then set the ID here. It's not the end of the world. John. But there are cases where you really have to initialize an object to an early state. What is an example of that? Let me show you. So I want to create a new class. Let's call it order. Public class order. Let's not worry about the fields in this class for now. So I'm going to put this in a separate file. Put the cursor here. Alt and enter. Enter. Done. Now go back to the customer. In the customer, we want to create a list of orders. So we use the list class. Public list of order, and we call it orders. In case you're not familiar with this list is a generic class that takes a parameter. This is what we call a generic parameter. So it represents a list of objects, and this parameter here specifies the type of those objects. So in this list, we can store objects of type order. Note that this list is declared in the system.collections.generic namespace. And here, because I'm using ReSharper, as I was typing list of order, ReSharper automatically added that using statement on the top. If you're not using ReSharper, you have to manually add this statement. Okay, let's move on. As a rule of thumb and as a best practice, whenever you have a class, like here, and that class has a list of objects of any type, always initialize that list to an empty list. What I mean by that is, in the default constructor here, we go and type orders equals new list of orders. Now you might wonder why. I think the best way to explain it is by showing what would happen if we didn't do this. So let me just comment this out. To do this, with ReSharper, you can press Ctrl and slash. If you are not using ReSharper, Ctrl K, Ctrl C. All right, let's go back to the program. Let's add a new order for this customer. So I'm going to create var order equals new order. Now let's say customer.orders.add this order. If we run the application now, it's going to crash. We got an exception, a null reference exception. The reason this happened was, let's close this, because orders was not initialized, and by default, because it's a reference type, it was set to null. So when we call the add method on a null object, we get null reference exception, which is a very bad thing. That's something we need to avoid at all times. Now, an amateur programmer may solve this problem by doing something like this here. So saying customer.orders equals new list of orders. That may look like a solution, but it's actually a bad solution. In fact, I wouldn't even call it a solution. It's a hack. It's a patch. Why? Because here, in this main method here, we should not be responsible for initializing that orders list to an empty list. It's not the responsibility of this class here. This class just wants to add an order to this customer. It's the responsibility of the customer class to make sure that its orders field is initialized to an empty list, and it's not a null object. If we take this responsibility from this customer class and initialize that orders field somewhere else, then it's going to be a problem. Because everywhere in our code we are going to use a customer object, we have to remember to initialize that orders field. Okay, so I'm going to remove this line here and go back to the customer class. In the default constructor, I want to make sure that the orders field is always initialized to an empty list. So that's the rule of thumb. Whenever you have a class and that class has a list of objects, make sure that list is always initialized. Now we have another problem here. If we use this constructor here, everything is good. The orders field is initialized. But what if we use either of these constructors here? Orders is going to be null. Well, we can go and copy paste this line into these constructors, but it's not really a good way. What if we had three other fields here that they all were lists? So we had to copy paste 3 lines of code into each of these constructors here. Is there a better solution? Of course there is. We can use this keyword. Let me show you how it works. So here in this constructor, upon declaration, I would put this and put the brackets like this. This means when this constructor is being called, first it's going to call the constructor without parameters. So before this line is executed, this constructor is going to be called, which will initialize the orders field, and then we get into this constructor here. Let me show you another example to make sure we really nail it down. So using a similar technique, I can go to this constructor and colon this. Note that we have two constructors here now we can call. One is the default parameterless constructor. One is the one that takes an ID. I'm going to pass this ID that is coming here into this constructor and then get rid of this line here. What this means is when we use this constructor to initialize the customer object, first it's going to call the constructor that takes the ID parameter. So we're going to go here. And note that here, before this code is executed, we're going to go here. At this point, the orders field will be initialized. Then we get back here, the ID will be initialized. And finally, we'll get back here, the name will be initialized. So what I want you to learn here is that we can use the this keyword and specify any of the other constructors we would like to pass the control to. Now here we have a simple example, and it's kind of okay to pass the control from this constructor to this one to this one. But in general, this is not considered a good practice because it makes the control flow a little bit complicated. For example, imagine someone else had written this code and you had to maintain it. You look at this constructor and then you had to look somewhere else and then you had to look somewhere else. It's a little bit ugly. So what I suggest to you is keep the using of this in this way to a minimum and only define a constructor when you really have to initialize some fields of your class. In this example, I explained to you that we really have to initialize this orders field here. So we created a default constructor. I can argue that these two are really redundant and they're just making the code a little bit ugly and hard to maintain. So it's okay to remove them, but I'm just going to keep them here because I wanted you to learn a few concepts here. One is the default and parameterless constructor. Another one is the concept of overloading constructors. That means we have 3 different constructors, each has a different signature, and how we can use this keyword to pass the execution to another constructor in this class. Well, that's pretty much it for this lecture. I hope you enjoyed it and thank you for watching.
Hi guys, Mosh here. I hope you're having a fantastic day or night wherever you are in the world. This tutorial you have been watching is actually part of one of my C# courses where you will learn everything about classes, interfaces, and object-oriented programming. In case you're interested to enroll in the full course, I've put the link for you in the video description. And if not, that's perfectly fine. Have a great day.